Hi, welcome you all on Physics Addhyan. So till now we have studied about the matrices and we solved some of the problems and discussed few definitions and tried to convey a message on how important the matrices are for physicists. So now we are going to discuss about the vector algebra. So vector algebra, while dealing, there are different type of coordinate system. So like say Cartesian coordinate system or spherical or polar or hyperbolic or cylindrical coordinate system, whatever. So before going to that coordinate system, before writing the vector and its derivative and its integral, its gradient, its divergence and in curl, let us have a detailed and in general discussion about the coordinate system. So till now, I hope that you all are familiar with the Cartesian, spherical and polar coordinate and we will revisit it. But while you write the volume in a spherical coordinate system, it turns out to be r square sine theta, dr, d theta, d phi and its integral. So that is the total volume. So how that r sine theta and 1 came from? Okay, so there is a system that look a coordinate system that is called the curvilinear coordinate system. That is the most general thing to define all the coordinate system and its various elements. So in this vector algebra course, we are going to define all these things in detail. So uh, let us have a motivation why we need to study the coordinate system, because you need to analyze a problem. So if you let's say there is a ball that is rolling, let's say there is a disk, uh, and there is a person that is rolling, that is standing on the disk and the disk is rotating. And if say you want to study the dynamics or you want to study the dynamics of this motion or whatever you want to study, either you choose the Cartesian coordinate system, but then you will find that the polar is more useful or convenient way to solve that problem. So depending upon the situation, you have to switch from one coordinate to another coordinate. Like if you have a charge that is distributed over a sphere on the inside or on the surface, then one may use a Cartesian coordinate system to deal with that problem, but one will find a very easy way to solve the same problem while choosing the spherical coordinate system. So choosing a good coordinate system will always lead to analyze a problem in a better analytical way, and second thing, it will help you to reduce your mathematics. And the last motivation for this is whenever you try to solve a problem, a physical problem, you have to fix a coordinate. Then you have to define the line element, the surface element, the volume element, or whatever you are using it. Okay, so for that, let us discuss the basic, the most general coordinate system, that is the curvilinear coordinate system. So let's have a introduction. So the marker problem is now solved. You can see, you can see a dot in the marker. Let me remove it. Okay, so now you can trace where the marker is. Most of the persons have the problem that you cannot trace where the marker is. So I think you are familiar with the Cartesian coordinate system. So in Cartesian coordinate system, you deal with x, y, z. Okay. Or in 2D, if I say this is in 3D, if in 2D I say you will deal with commonly x and y, and you are also familiar with polar coordinate system, where you deal with this r and theta, that is the radial distance and angle theta. If one should know is eager to know the relation, then there's some relation exists between these two coordinate system. X is equal to r cos theta, you can simply put, and y is equal to r of sine theta. So one can simply substitute in another way. You can also check r is equal to under root of x square plus y square, and your theta is equal to your tan inverse of mod of y by x. You can, okay, so these are relations. This is relation, you know, x and y Cartesian coordinate system, and you define this Cartesian coordinate system into polar. You know the polar r and theta, and then you define the relation between y and x. So that is just the introduction. So let's have in general, I am not using x, y, r, theta, phi. We will using general coordinates, that is u, v, w, or u1, v1, w1, whatever. So then we will define the most general case. So let me write it here. So let me go to some specific definitions over here. So let me write here, that is the transformation of coordinates. So transformation of coordinate system, coordinates. So as you know, if I work in Cartesian coordinate system, let's say there are few points in a space. Let's say there is a point in a space that is written in x, y, z. Okay, and if I say that suppose these rectangular coordinates of any point in a space, these are expressed as a function of, let's say, u1, u2, and u3. So you can write x as a function of u1, u2, u3. Similarly, y as a function of u1, u2, u3, and z as a function of z, which is a function of u1, u2, and u3. In the same way, you can invert these equations and you can write u1 as a function of x, y, z, u2 as a function of x, y, and z, and u3 as a function of x, y, z, as seen in the previous example of Cartesian and polar. So let us call these equations as 1 and let us call these equations are 2. So there is a condition between these equations 1 and 2. What is that? That the function that is in 1 and which are is in equation 2, which are assumed, that the functions are assumed to be single valued, first thing, single valued function, and they do have the continuous derivative, so that why this is needed, so that you can say the corresponding between, so that the correspondence between these coordinates, which are called at x, y, z, and the second one is your u1 comma u2 comma u3, they are unique. Means there is a unique relation between u1, u2, u3 and x, y, z. So for this you have to specify these two conditions, that function 1 and 2 should be single valued, that for each, let's say on y is equal to fx graph, so for each x you have a single value of y, and they must have a continuous derivative in all this space, so that these functions relations is unique. So that is the very first condition. Okay, so this assumption may not apply at certain points and special consideration is required. Okay, so that was the thing about the function or the transformation of coordinates, first thing. So now let us define some what I mean by curvilinear here. I just defined the curvilinear coordinate system. So I have given you the rectangular, let's say I have given you a rectangular coordinate system x, y, z as previous, and I defined a unique relation between x, y, z and u1, u2, u3. So these are called curvilinear coordinates. Curvilinear coordinates of some point P, that is x, y, z. So if there is a unique relation if there is a unique set of coordinates for x, y, z, that is u1, u2, u3, for every point in the space, that is x, y, z, if there correspond a unique relation such that let's say that the relation is u1, u2, u3, that is called the curvilinear coordinate of P. Okay, and the set of equations, so there must be an equation between x and y, as we have seen that x is equal to r cos theta and y is equal to r sin theta in previous polar and Cartesian. So there are some set of equations, between these 1 and 2. These are called transformation of coordinates. Okay, so this was about how the transformation of coordinates take place. Now we are going to deal with some specific kind of transformation of coordinates. Now here the topic starts: orthogonal curvilinear coordinates. So now I think curvilinear has a better meaning, a better picture in your mind, that there exists some relations between old coordinate and new coordinate, which we are going to define. And orthogonal, I mean that all the coordinates, if you let's say what you know x, y, z, if you know x and y, if you take the dot product of x and y, it will become 0. It means x and y are orthogonal. So we are going to deal with orthogonal curvilinear coordinate system. So as I told that we are going to study in general the orthogonal curvilinear coordinate system in general. So I will emphasize, or I will try to understand you the thing which I am going to say and relate it with your Cartesian coordinate system, so that you can have an idea what I am talking about. Because these curvilinear coordinate system, if once get out of attention from any reason at any instant of time, he will lose whatever I was saying. So what I next say, I will define some things. So there are surfaces, okay, in a specific coordinate system. What are surfaces? If I say I am a u1 coordinate system and u2 x coordinate and u3 axis, if I say that let u1 is equal to c1, u2 is equal to c2, u3 is equal to c3, and these c1, c2 and c3 are some constants. If they are constants, so these are called coordinate surfaces. These are called coordinate surfaces. Okay, what I mean is, and let me define one more thing, then I will specify the same thing in Cartesian coordinate system. So these are called the coordinate surfaces. And the second thing is, each pair of these surfaces intersect, each pair of these surfaces intersect is curve, that is a curve called the coordinate curve, or you know a better name, that is lines. So let me define these two things, this first and second thing, in Cartesian coordinate system. Okay, so suppose I have a Cartesian coordinate system. Let's say this is your x, this is your y, and this is your z. Okay, so if I set x is equal to 0, so similar, your x is here u, treat it as, if x is equal to 0, then that is the yz plane, yz plane. So that is this whole plane I am talking about at x is equal to 0. So this is your yz plane. So this is a surface. So these are called the coordinate surface. Similarly, if you put x is equal to 3, then this surface will shift out here and there. If I say that is let's say y is equal to 3, then there will be a similar plane at y is equal to 3, so that will be in xz direction. Okay, so this was about the coordinate surface that you already know, and this is in Cartesian coordinate system. And the second thing is each pair of these surfaces intersect is curve called coordinate lines, coordinates curves or lines. Let's say again, let took one more example, y is equal to 0. Okay, let me draw it with another color. If I took y is equal to 0, so it means that is a xz plane. So this plane must look like this if it is a xz plane. So let me draw like this. So this is a xz plane. So there is a yz plane and there is a xz plane. So this will intersect at a common point. So I'm saying that there is a one plane over here and there is another plane, let's say like this. So it will intersect at some point. So that intersection is called a coordinate curve or a line. Or like say if xy plane and xz plane intersect at line that is in z direction. Okay, in the similar picture, that is x is equal to 0, that is your yz plane, and y is equal to 0, that is your xz plane. So the point of intersection, or the points of intersection, the locus of point of intersection of these planes is the z-axis. So that is called the lines. So this was in general. So I will try to treat or try to uh, get these things visualized by Cartesian coordinate system. Okay, so these were the two things: how I define my surface and how I define my lines. Okay, let's move further. So I have defined that thing in a particular xy coordinate system. So let me define the same thing in some general coordinate system. So let me draw. So that is the thing. So suppose there is a Cartesian coordinate system xyz, which you know. I draw some lines. So let me draw like this, draw like this. Okay, I will explaining why I am drawing like this. Okay, let me have some another pictures like this. Mm, okay, so I have drawn some surfaces, and let me call this surface, this particular surface, this particular surface as u2 curve. u2 is equal to c2. So likewise x is equal to 0. So that is in general. So u2 is equal to c2 is a surface. This is one u1. Let's say this is u1 is equal to c1, and this is u3 is equal to c3. So these was the surfaces. So let us define the curve. Let's see. There is a u2 and u3. So likewise we have defined yz and xz plane. So the points of intersection was in z. So that is u1. So this curve will lead you u1 curve. This curve, that is u2 and u1. So this curve will lead you u3 curve. And this is u1 and u3. So this curve will lead you u2 curve. So that if they are perpendicular xyz, so this is your this transformation. In general, if it can take any shape, so I have drawn some coordinates and fixed this surface is some constant. So this is your u2 curve, u1 curve, and u3 curve. So these were the things. Now the second thing and the very important thing is to define the unit vectors in this coordinate system, which is replaced by u1, u2, u3. So we have some general coordinate system that is defined by u1, u2, u3. Now what are the unit vectors or unit tangent? If I know the vectors, then I can find out the unit tangent vector. Then there will be something called that are the scaling factors, and then we will move to some general things like Cartesian and coordinate systems. By once we define the scaling factors, then we will move to some coordinate system. Then we will again come to this general concepts, and then we will deal about gradient, divergence, and curl in general in this type of coordinate system. And then we will deal about the specific, that is Cartesian, spherical, polar, cylindrical, in these types of coordinate. So in the next lecture, we are going to define with unit vectors in curvilinear system. So this was just an introduction. So in the upcoming lecture, we will be dealing all the topics which I just said. So, okay, thank you.